All right, today we are going to start lesson 9.5 where we are going to work on factoring. Now, we have actually talked about factoring before. So before we jump into today's lesson, I want to point you back to something we have done in the past. Now, no need to turn here in your notes unless you want to, or in your, this is actually going to be in your discussion questions. You don't need to go there unless you want to. You can just watch the video and follow along with me. All right, so as you remember, we have all year been looking at these algebra blocks and talking about how they help us better understand distributing and multiplying and all those types of things. But I want to go back to them today because they're going to really help us when it comes to this factoring. So I pulled an example that we did in our last set of algebra block, or our last set of discussion questions. And I want to point your attention most specifically to part D. All right, so part D says draw a rectangle using the appropriate number of x squared blocks. Remember, that's one that has the dimensions x times x blocks, which has the dimensions x times 1, and 1 blocks, which would be 1 by 1. To illustrate the distributive property that x plus 2 times x plus 3 equals x squared plus 5x plus 6. What is the length of the rectangle? What is the width? What is the area? All right, so first of all, remember when we talked about setting up our algebra blocks, we can only match x sides with x sides and one sides with one sides. And so if you remember, I'm going to zoom in here on part D. I said if we had x squared plus 5x plus 6, this would be 1 x squared block, 5 x blocks, and 6 1 blocks. And the task that I gave you was to use all of those blocks and make a rectangle, okay? So if you look over to what we drew here, we talked about how we can put that x squared block in the corner. And one way we could do it would be 3 x blocks to the side and 2 down below, or that could be flip-flopped. So you see we have the 1, 2, 3, 4, 5 x blocks, and then the 6 1 blocks that fit in there. And we talked about how this worked because 3 plus 2 adds to 5 and multiplies to 6. And so we could factor x squared plus 5x plus 6 to be x plus 3 times x plus 2. Let's look at another example. Here's a couple more that we did from our discussion questions as well. And so the one in the example to begin with told you you had 1 x squared block, 2 x blocks, and 1 1 block. And so here's the picture that we made. And again here, we see that 1 and 1, well, those are the ones that work, x plus 1 and x plus 1. And again, you can see like that's this side length here, guys, x plus 1, and this is x plus 1. And 1 plus 1 equals 2, and 1 times 1 equals 1. Then I gave you another one, and I said, okay, what if you have 1 x squared block, 6 x blocks, and 8 1 blocks? And y'all played around with making those pictures, and we came to figure out that we could put 4 x blocks along the side and 2 along the bottom, or you could have done 2 on the side and 4 on the bottom. And then you filled in the 1 blocks. And here we see that this side is x plus 4, because again we have that x side and then 4 1s. And then this is x plus 2. And so we talked about how x plus 4 times x plus 2 would give us the 1x squared plus 6x plus 8 that we were looking for. And again, we talked about here how 4 plus 2 equals 6 and 4 times 2 equals 8, which is why 4 and 2 work there. All right, I'm going to give one more that we're going to talk about that we hadn't talked about yet, okay? All right, so let's say I tell you you have to use 1 x squared block, 7 X blocks and 12 1 blocks. And as we talked about, it's easiest to start by putting your X squared block in the corner. So I have X times X. So if you want, you can create a new page in your notes or open up a new Notability document or just sketch this on scratch paper or really just think about it in your head. But take just a second and see if you can figure out how you would set this up to use 7 X blocks and 12 1 blocks. All right, well, maybe what you came up with is that I could put 4 X blocks along the side here, 3 going down here, and then this would have my 12 1 blocks there. And you could have put 3 along the side and 4 going down. But what works about this here is that this side is X plus 4. This side is X plus 3. Notice we have the 1X squared block, and then we have 1, 2, 3, 4, 5, 6, 7 X blocks, which is exactly what we needed. And then in here we have the 12 1 blocks, which is also what we needed. So we can say that X squared plus 7X plus 12 equals X plus 3 times X plus 4. Because 3 plus 4 equals 7 and 3 times 4 equals 12. So if we were to multiply the binomials, which is what we did in our lesson yesterday, we see that when we multiply, we take that X and we do it times X, which is X squared, and then times 4, which is 4X. And then we've got to take the 3 and multiply it by both parts. So this would be 3X plus 12. And we combine like terms and we get that X squared plus 7X plus 12. So we've spent a lot of time multiplying and distributing, and today we're going to do the opposite. We are going to factor. Now we've done some factoring before. We've talked about how factoring is breaking something into its pieces. And so today I am going to give you this, the X squared plus 7X plus 12, and you are going to need to factor it into the 2 binomials that make it. And again, these algebra blocks are a great way for us to visualize what's happening. Now, just like many of our tools, we don't necessarily want to have to draw algebra block diagrams every single time that we do one of these problems. And so we're going to learn some tricks and shortcuts and practice this enough that we don't have to make algebra block diagrams every time. But the algebra block diagrams are a great way for us to visualize what is happening. And so if they help you, by all means, you should use them. All right, so now we're finally ready to start writing stuff in our notes. But again, we're going to keep referring back to what we just talked about in those algebra blocks. So it says here when we have X squared plus BX plus C. And so B and C are going to be numbers there. We're just representing those with variables because they could be any number. We can factor that into X plus P times X plus Q, provided that P plus Q equals B, which is that middle term, and P times Q equals C, the last term. Okay, and that's what we just talked about. If you go back to that last example, we talked about how 3 plus 4 was 7, which was the middle term, and then 3 times 4 was 12, which was the last term. So here's another example. We have X squared plus 6X plus 5. So I need 2 numbers, P and Q, that are going to add to 6 and multiply to 5. Well, I can say here X plus 5 times X plus 1, because 5 plus 1 is 6 and 5 times 1 is 5. Again, I'm looking for two numbers that add to the middle coefficient and multiply to that last term. Now, when you're writing these, it does not matter if you put x plus 1 times x plus 5 or x plus 5 times x plus 1. The order doesn't matter. All right, so let's try this next example together. We have x squared plus 11x plus 18. So one way that you can do this is you know that the two numbers that you need have to multiply to that last number. So we can start listing factor pairs of that last number. So we can say that 1 times 18 equals 18, or 2 times 9, or 3 times 6. Those would all be pairs of factors of 18. Now, let's see what those add to. Well, 1 plus 18 equals 19. 2 plus 9 equals 11. And 3 plus 6 equals 9. So we need the pair that multiplies to 18 and adds to that 11, which is the middle term. So we know that 9 and 2 would be the pair of numbers that we need. So the factors 2 and 9 have a sum of 11. So they are the correct values of P and Q. So we know that this trinomial factored would be x plus 9 times x plus 2. And again, as I mentioned before, it doesn't matter if you put x plus 2 times x plus 9 or x plus 9 times x plus 2. It makes no difference. And then you don't have to do this step, but I am going to show you that you can very quickly check that you got the right thing by multiplying the binomials, which is what we did in our last lesson. So I'm going to take the first term x and multiply it by both terms in that second binomial. So I get x squared plus 2x. Then I'm going to take the 9 and multiply it by both terms in that second binomial. So I get 9x plus 18. I'm going to add like terms, so I get x squared plus 11x plus 18, which is exactly what I started with, so I know I got the right thing. So your answer here, guys, is x plus 9 times x plus 2. The directions asked you to factor that trinomial, and so those two binomials are what you get when you factor it. That's your final answer. All right, let's try some more. Again, you don't need a chart, but you should always start by thinking of factor pairs of the last number. Well, in this one, I have x squared plus 3x plus 2. So when I look at that 2, the only pair of factors is 2 and 1. 2 times 1 is 2. So I'm just going to do a quick double check. 2 plus 1 is 3, which, yes, that's the middle term. Guys, this right here is the work that you need to show. You need to show that the two numbers you're choosing multiply to the last term and add to that middle term. So make sure you're showing that work. And so here I know that my answer is x plus 1 times x plus 2. That's my answer. You're welcome to multiply those binomials to double check it, but your answer is the two binomials. Let's do number 2. All right, when I look at number 2, I have a squared plus 7a plus 10. So I'm going to start by focusing on that last number. I know factor pairs of 10 could be 1 and 10 or 2 and 5. Well, 2 times 5 is 10 and 2 plus 5 is 7. So I know that that's the pair that I need to use. So I get a plus 2 times a plus 5. That 2 and 5 are the P and Q values that I need. All right, why don't you turn the page and take just a minute to try 3 and 4. So pause the video, try 3 and 4, and then press play when you're ready to check again. All right, go ahead and check your answers with mine. Notice that I started by finding factor pairs of that last number. So on number 3, 2 and 7, multiply to 14 and add to 9. So I know that my answer needs to be t plus 2 times t plus 7. Let me point out to you real quick a common mistake people make. is instead of using the 2 and the 7 in their binomials, they get mixed up and use this 14 or 9. Remember, the 14 and 9 are the numbers that you see in the trinomial, but you're trying to figure out which two binomials are going to multiply to that trinomial. And so typically P and Q, which are these here, are not necessarily going to be the same numbers that you see here. They could be, but they most often are not. So just make sure you're really careful there. Number 4 should maybe have looked familiar to you because that's really similar, or that is actually the exact same as the one that I gave you in the algebra block project problems early on. So again, if those algebra blocks help you, if it helps you to visualize this as a rectangle, by all means, you should keep sketching those to help you. But essentially, you're looking for two numbers that multiply to the last one and add to the middle term. All right, the last thing we're going to look at in today's lesson is just the start of this table, and this is where we'll pick up in our next lesson. But let me give you an example. If we have, let's say, x plus 3 times x plus 2, so 3 is P and 2 is Q. When we multiply that out, we get x squared plus 5x plus 6. And this is the type of problem that we've been looking at where B is positive, in other words, the middle term is positive, and C is positive. And if both of them are positive, then we know that P and Q both need to be positive as well. And so in your assignment today, everything will be positive, okay? Because we're just getting used to this idea of factoring and breaking that trinomial into its pieces. And then in our next lesson, what we'll add in is when we have negative terms in there as well, and what happens if one of those terms, either B or C, is negative. So that's where we will jump in with our lesson the next day. All right, that's all for today. Have a great day.